Hey everyone, and welcome to this explainer. I am absolutely thrilled you're here today because, well, we are going to make sense of something that quietly runs pretty much our entire modern world. We're talking about how information is organized. Today, we're demystifying databases, taking them all the way from old school paper systems right up to modern digital pixels. And don't worry if you're a complete beginner. We're going to break this down so simply that by the end of our time together, you are going to see databases literally everywhere you look. So let's just jump right in. I actually want to start off with a really simple question. Have you ever used a physical phone book to find a number? Or, maybe a paper street directory to find an address? Before we even touch any kind of computer jargon, I really want to anchor us to that totally familiar, everyday physical tool. Because if you have ever flipped through the white pages to find a local business or a friend's phone number, well, congratulations, you actually already know exactly how to use a database. It really is that simple at its absolute core. So here is our game plan for today. First, what exactly is a database? Second, we'll look at the anatomy of a database. Third, making sense of it all with reports. And finally, number 4, why we made the leap to go digital. Part 1, what is a database? Organizing the chaos. Think about raw data for a second, just random numbers, names, and addresses floating around totally on their own. It's essentially useless, right? It's just chaotic noise. To actually make it useful, we have to define it. A database is simply data that is arranged so that it can be searched, organized, and selected, showing how items relate to one another. The true power of a database isn't just hoarding facts. It's organizing all that chaos into pure clarity so that people can actually interpret the information and make informed decisions. And seriously, databases are everywhere. They're not just some complex thing for massive tech companies. They exist all around us in our day-to-day lives. That simple telephone directory? That is a database. The records of students attending a school? Yep, database. Think about a supermarket inventory tracking what's being sold, your personal bank customer accounts, the whole catalog of books in your local library, or even just a list of members down at the local tennis club. Whether it's kept in a slightly messy notebook in a desk drawer or on a massive bank server, they are all doing the exact same fundamental job. Part 2, anatomy of a database, the building blocks. Okay, so to look under the hood, I want you to imagine a classic physical filing cabinet. Our very first building block is something called the entity. The entity is just the subject we are collecting data about. Think of this as that main paper label slapped right on the front drawer of that filing cabinet. If our database is a telephone directory, the entity is simply the subscriber. If it's a library, the entity might be a book. It's basically the who or the what that the entire database is entirely focused on. Next up, we have the record. A record is a single, complete piece of information about an entity. Going back to our filing cabinet analogy, a record is one single, whole index card that you pull out of that drawer. In a phone book, a record represents all the collected data for one single person. So their name, their address, and their phone number, all bundled together as one complete entry. And finally, we have the field. You see, a record is made up of separate, specific pieces of data, and each of these little pieces is called a field. Think of fields as the individual blank lines you have to actually fill out on that index card. Each field is given a specific name so it can be easily recognized, like first name, last name, or phone number. By breaking a record down into these fields, we make sure every single piece of data is neatly labeled and strictly categorized. So let's see how this actually maps out in practice. Imagine we have a single subscriber's record for someone named WJ Agua, and it's broken down into specific fields. We have our specific field names, things like family name, initials, P.O. box, town, street, main town, and telephone number. And alongside those, we have the actual data filling each of those fields. Because the data is strictly separated into these perfectly labeled little boxes, a computer, or even a human, can easily search for, say, everyone who lives in Pete Moresby, or everyone on Hunter Street. It perfectly maps the real, messy world into a beautifully organized system. Part 3, making sense with reports. Finding the signal in the noise. Now, perfectly organized data is fantastic, right? But looking at millions of records all at once isn't exactly helpful for human eyes. We need a way to extract just what we care about, and that is exactly where a report comes in. Honestly, generating reports is one of the most absolutely crucial uses of a database. A report basically acts like a really smart filter. It makes a specific selection from the entire database and arranges that data so it can be easily understood. Instead of overwhelming you by dumping the whole filing cabinet on your desk, a report normally only shows the specific necessary fields you actually asked for. And even better, it often gives you really helpful totals or summaries of that information. Let's look at a report in action, using some really fascinating historical data from the First Fleet. Out of all the incredibly complex data available, a rule was applied here to only select people whose position was listed as convict. Then, the report was told to only display specific fields: first name, last name, sex, position, ship, and date of trial. And finally, it sorted this whole neat, easily readable list alphabetically by the person's last name. It took raw, overwhelming historical records and made them incredibly simple to read and analyze. Or think about a really common everyday example, like customer records from a retail store. A report here might pull the customer's name, the value of their purchase, the date, and the specific department. I mean, imagine how much easier a store manager's job becomes with this. Because of how reports summarize data, that manager could easily ask the database to total up all the purchases specifically in the sports department, or effortlessly tally up all the sales specifically made on January 22nd. Reports are what take the organized data and make it actually work for a business. Part 4. Why go digital? Escaping the paper trail. Okay, so we've established that a database could easily just be an address book you keep in your kitchen drawer. So you might be wondering, why on earth did we bother moving all these paper index cards onto computer screens? Well, imagine a paper database for a massive global bank. Finding just one customer means a human being has to physically walk over to a filing cabinet, find the exact right drawer, look past hundreds of alphabetical folders, and physically pull out a piece of paper. It is incredibly slow, tedious, manual work. A computer database escapes this physical limitation entirely. Going digital is a total game changer. It completely transforms how businesses operate, offering just immense relief and efficiency. Digital databases can store massive, almost unfathomable amounts of data in a tiny physical space. They can find and display information literally instantly with a simple search. If someone moves house, well, their record is quick and easy to update without having to erase or rewrite a messy paper card. Data can be transferred across the world in milliseconds via the internet. And perhaps most importantly of all, a huge number of people can view and use the exact same database at the exact same time from entirely different locations. I mean, good luck trying to get 50 people to look inside the exact same filing cabinet drawer at once. So how do we actually set one of these up? Creating a digital database is a highly logical, step-by-step process. Step 1. Identify the entity. Who or what are we storing data about? Step 2. Define the specific fields that will make up each record. Step 3. Enter the initial data and meticulously check it against your original documents just to make absolutely sure it's correct. Step 4. Work out the common reports and searches you're going to use often. And Step 5, and seriously, I cannot stress this enough, back up your database regularly. Storing copies in a safe place is absolutely critical whenever a database is altered. So let's see how all of this builds into a final product. Think about a fully functional digital database for that local tennis club we mentioned earlier. You'd have fields like title, first name, surname, address, town, and telephone. But there's usually one very special field right at the beginning, a member number. When setting up a computer database, the software usually assigns an automatically generated unique ID, which is known as a primary key. And this is a brilliant feature. Because, two people might share the exact same first and last name, right? But this primary key ensures that the computer can uniquely and perfectly identify every single individual record without ever getting confused. It's like a perfect digital fingerprint. As we wrap up this explainer today, I actually want to leave you with a rather mind-blowing realization. Think about everything we've covered, from school records to supermarket purchases, bank accounts, and phone directories. Just ask yourself, how many databases is your personal information sitting in right now? From the very moment you were born and entered into a state registry, so much of your daily life is quietly organized into records and fields on servers all across the globe. It really makes you appreciate the invisible architecture that keeps our modern world spinning, doesn't it? Thank you so much for joining me to demystify databases today. Stay curious out there, and I'll catch you in the next explainer.